Welcome everyone. This is a webinar for the Less Mites More Feed project, an MLA producer demonstration site project funded by Meat and Livestock Australia. I'm Matt Marnie from Agridome Consultancy. I'm the project lead and coordinator for the Northern Vic region. I oversee project activities and coordinate project and extension activities in the northern region of Victoria for the project. I'm also joined in alphabetical order by Aston Arthur from Caesar Australia, Sinead Barker from Perennial Pasture Systems. So Aston has been responsible for overseeing all of the bug assessments and reporting from each site, both Northern and Western Vic regions. And Sinead, and for a large part during the project, Rob from PPS was the project coordinator for the Western Vic region, responsible for project activities and extension in the Western Vic region. Hello and welcome to you all, and thanks for joining us on this webinar. Today's webinar is the final one in the series for this project, and as it enters the final stages of completion, please do look back through the information available on the project on the MLA website for the previous webinars, as they have some great information, and also for the fact sheet, which has been developed as a legacy document for this project. Just a quick overview for the project. So as with all PDS projects, they are aimed at demonstrating best management practices. There's nothing like seeing something on your own farm before putting it into practice for yourself. The main objective is to demonstrate some clever online decision aid tools, which are available on the Caesar website. Look for the resources page. If not already, please be sure to look these tools up. As you'll learn further with this webinar, they are great tools. So 2 farmer networks participated concurrently in 2 different regions of Victoria with this project, and we had multiple demonstration sites in each region over the 3-year span, and with sites at Wonalta, Strathallan in Northern Vic, and Mount Coal Creek, Mount Dryden and Tarana in Western Vic. Starting in the summer of year 1, we needed to know when red-legged earth mite would start to hatch. If we were to go too early, we run the risk of finding none and thinking we don't have any, which, if they haven't hatched yet, could be misleading. So the first tool we demonstrated was the hatch timing tool. So there are the 3 tools, and the first one we used was that hatch timing tool, which was we found a great tool so that we knew when to start looking, when to expect those mites to hatch. Alongside this was the severity risk calculator online tool, so tool number 2, which gives us information on what to expect based on the history of the paddock, what was grown in there for the last year or so, and if it was a brassica crop, or depending on the crop, can significantly affect the severity of the hatching we can expect in that year. Then, as the year rolled on, we looked at additional nearby sites which hadn't had any red-legged earth mite control sprays applied, and we assessed for the presence of red-legged earth mite. We used these sites to demonstrate the effectiveness of the time right spray, a very effective red-legged earth mite control method which has been around for decades now. So for the final year of the project, we demonstrated the recently completed revised tool number 3. So the time right tool has been revised. Simply put, the dates are different, generally a few weeks earlier. So the window is a bit earlier when we spray now in the spring for your region. And we found this made a pretty big difference. Once the sites were selected, treatments were imposed, and measurements were then taken to compare the treatments both before and after. And so we've got some great data coming up from Aston when she talks about that. So the measurements we were interested in show the effect that the red-legged earth mite treatment has on not only red-legged earth mite numbers, but also other species of bugs as well. As we know, there are lots of different species present in our pastures. Some of them good and some of them not so good. We also used the MLA pasture ruler to estimate pasture dry matter responses, as well as pasture species measurement charts to monitor pasture species composition changes due to the red-legged earth mite management practices. We had also demonstrated and utilised the MLA pasture paramedic tool as part of this project in the first year. Each step of the way during the project, the relevant online decision aid tool was consulted and the outcome implemented. So, for example, we waited for the hatch tool to tell us when the majority of mites should have hatched for our host farm for the particular location before we went looking for red-legged earth mite. The hatch timing tool is a nifty tool because you could go too early and find no mites and assume there weren't any. However, using this tool ensured we were looking for mites at the right time. The online decision aid tools can be found on the CSER Australia resources page on the CSER Australia website, and the address is shown on the slide if you can see that at the moment, which is cseraustralia.com/resources. So the 3 different tools were developed for helping with red-legged earth mite management. And the hatch tool, as mentioned, can be used to let us know when red-legged earth mite should be hatching in our area. And that's helpful to know when you should be looking for them. Non-residual insecticides used before red-legged earth mite hatch would ultimately be a waste and possibly lead to chemical resistance in other species. The risk tool gives us an indication of the severity of the red-legged earth mite given past history events such as crop grown and management strategies used in the year prior. And this tool tells us what our risk is likely to be in the coming season. The time right tool is used in the lead up to the spring and gives us a date based on our location again, which is the time recommended to spray. So it gives us a window at which we can spray the red-legged earth mite to reduce the over-summering eggs, which will otherwise give rise to the new red-legged earth mite population the following autumn. So you'll see when Aston presents our data that we've really reduced, by using this tool and spraying at the correct time in that new window, that we've really reduced the numbers in our pastures as our autumn starts to kick off in the following year. As mentioned, so this has led to the revision, revision recently, and the latest version is what we're looking at, what we looked at in the final year of the project, and that's what we'll be presenting the data on in this webinar. Now I'll hand over to Aston to give us an overview of the red-legged earth mite biology, life cycle, and the decision aid tools. Some recent data collected and yeah, just what has been done to revise the new time right tool. So over to you, Aston.
Hi everyone. So I just thought I'd start off with a brief rundown on red-legged earth mite biology. So as a bit of a refresher. So red-legged earth mite is one of the most destructive and economically important pests of winter grain crops and pastures in Australia. They are found in areas of southern Australia with a Mediterranean type climate, and they're active from around April to November, depending on the region, and they survive the hot, dry summer months as diapause eggs. They attack a wide range of plants, with clover, medics, forage brassicas, and canola being most susceptible, and they're most damaging in autumn at seedling establishment, with damage seen as silvering on the leaves, as shown on the photo here, and their feeding can cause reduced plant growth and seedling death, leading to reduced feed for livestock and reductions in seed yields, and in severe infestations, the crop may need to be resown. So there are a number of other pasture pests that occur together in the field that can be easily confused with red-legged earth mite, and it is important to be able to distinguish between different species and know what species you are controlling, as each species requires different management strategies. So red-legged earth mite, as shown in the picture here, are about 1 millimetre long. They have a black velvety body and 8 red to orange legs. In regards to other pasture mites, we have the blue oat mites up here on the top, which is probably the most common mite confused with red-legged earth mite. So blue oat mites, however, have a blue to black body. They have the 8 red to orange legs, but also have a red-orange marking on their back, which is a distinguishing factor from red-legged earth mites. So Bryobia mite is the mite here in the middle, and they are smaller than red-legged earth mites, and they have 2 long front legs and an oval-shaped flattened body that can range in colour from dark grey, pale orange or olive. Balaustia mite here at the bottom are about twice the size of red-legged earth mites. They are slower moving and they have a red to brown body that is covered in hairs, and they have pad-like structures on their feet, as shown here in the photo. So another distinguishing factor for red-legged earth mites is that they generally feed in clusters of up to 30 individuals, whereas these other pest mites here generally feed singularly. So currently control of red-legged earth mite is heavily reliant on insecticides through foliar sprays or seed treatments. There are only 6 registered chemical mode of actions for red-legged earth mite control, so only a very limited number, with 3 that can be applied as foliar sprays and 3 seed treatments, with 2 of these only being registered on canola. So there are very limited options, particularly after the crop has been sown. So the ones highlighted in yellow, which include the organophosphates, pyrethroids and neonicotinoid seed treatments, are the ones that are most frequently used by growers for red-legged earth mite control. So as a result of the extensive use of the limited chemical options to manage red-legged earth mite, this pest has a bold resistance to both pyrethroid and organophosphate chemicals, with some populations exhibiting dual resistance to both chemicals. So resistance was first detected in 2006, and since then resistance has been increasing over time, with more resistant populations and regions being discovered every year. So these maps show you where resistance is currently present in southern Australia. This here is the pyrethroid resistant map, and the other one is the organophosphate resistant map, with the orange circles showing where resistance has been detected in these regions, and the blue circles are susceptible sites. So as shown in the maps, resistance to pyrethroids and organophosphates is widespread in WA and also present within areas of South Australia. We have organophosphate resistance has been found in a few regions in Victoria, but pyrethroid resistance has not yet been detected in Victoria, and resistance has not yet been detected for any of these insecticides in New South Wales. So the limited chemical options and increasing expansion of resistance to organophosphate and pyrethroid chemicals does have major implications for how to manage red-legged earth mite in the future. So future management of red-legged earth mite must focus on reducing chemical use to minimise selection pressures and decrease the risk of further resistance evolving. There are some great tools and resources available, as Matt mentioned, to help growers and advisors manage red-legged earth mite in the face of increasing resistance and limited chemical options. And these tools support targeted monitoring and management of red-legged earth mite, optimising spray timing and increased confidence in managing red-legged earth mite risks. So the tools, as mentioned by Matt, include the red-legged earth mite hatch timing tool, the seasonal pest risk tool, TimeRight, and we also have the red-legged earth mite best management practice guide. And I'll go over each of these, and I'll briefly go over each of these. So the red-legged earth mite hatch timing tool is online, and you put in your town and it predicts when red-legged earth mite diapause eggs will hatch that season. So it is a tool you will need to check regularly in autumn, as it predicts the hatching on current weather conditions. So this tool helps growers and advisors determine if their emerging crop is at risk of red-legged earth mite damage, gives them an idea of when best to monitor for a red-legged earth mite, as it gives you the date they have or are expected to hatch. So overall, this tool optimises red-legged earth mite monitoring and management during that vulnerable seedling stage when red-legged earth mite are most damaging. So the seasonal pest risk tool is a multi-species tool for canola, but is expected to include other crops in the future. So this tool helps assess and manage risks from red-legged earth mite and includes some other pests. It helps determine whether the paddock is at risk of red-legged earth mite and the potential level of risk. This can help with management decisions regarding red-legged earth mite and determine whether red-legged earth mite need to be controlled with an insecticide. So the tool allows the user to explore the impact of various management options to reduce red-legged earth mite risk, improving overall management decisions. The red-legged earth mite best management practice guide is a really great resource to help with managing red-legged earth mite, and it's located on the GRDC website. So this guide was recently updated to incorporate the latest advice and provides best management practices for controlling red-legged earth mite throughout the season. It also helps assess red-legged earth mite risk and provides advice on how to manage red-legged earth mite with different resistances if it is present in your paddock. So one of the most effective tools for managing red-legged earth mite is TimeRight. So TimeRight is a highly effective tool as it improves the precision of chemical applications by targeting a critical stage in the red-legged earth mite life cycle. So this strategic timing significantly increases control efficacy and reduces the overall need for insecticide use to manage red-legged earth mite. So to give you an idea on how time mite works, you need to understand the life cycle of red-legged earth mite. So this figure here shows you the life cycle of red-legged earth mite. So red-legged earth mite are active in the cooler months, typically from April to November, and they survive the hot, dry summer months as diapause eggs, which hatch the following season, typically in autumn, with cooling temperatures and adequate rainfall, which generally coincides with the emergence of crop and pasture seedlings. So they start producing these diapause eggs in spring, triggered by day length, temperature, and soil moisture. So the TimeRight tool works by predicting the timing of diapause egg production and implementing control measures by providing you with a date to spray before this critical stage. So by controlling red-legged earth mite populations prior to diapause egg production, the number of over-summering diapause eggs produced is reduced, and in turn, the number of mites that hatch the following season is drastically reduced. This in turn protects emerging plant seedlings when red-legged earth mites are most damaging. However, there are some important points to consider when using TimeRight. So TimeRight is best used when the impact of red-legged earth mite risk is high the following season. For instance, you have high red-legged earth mite numbers in spring and are planning on planting a susceptible crop such as canola or a legume-dominated pasture the following season. Also, you need to ensure that red-legged earth mite is the dominant species present, as TimeRight is not effective on other pasture pests such as lucerne flea or blue oat mite. So TimeRight was originally developed by AWI and CSIRO over 20 years ago. It predicted the timing of red-legged earth mite diapause based on day length and long-term seasonal patterns. And the static model didn't account for the influence of changing climatic conditions. So the TimeRight tool has recently been updated with new data and improved modelling in response to changes in climate over the last couple of decades, and recent research also showing that temperature and moisture can also impact red-legged earth mite diapause timing. So the update also provides greater flexibility in spray timing. As you can see here, while it provides the best spray date indicated by the red line, it also now provides an ideal spray window, a date range in which control of red-legged earth mite is still very high, and that is the grey highlighted section here. So this allows greater flexibility to coincide with suitable weather conditions and or to integrate red-legged earth mite management with other farm operations such as disease or weed control, allowing more efficient overall farm management. So the web interface has also been updated and is more user-friendly, with growers only needing to put in their postcode to obtain their TimeRight best spray date, and farmers also now have the ability to visualise the impact on mite control if spraying is undertaken outside that ideal spray window. So these updates are based on the use of a long-term residual pesticide such as a methylate, which is LEMAT, and are expected to significantly increase the effectiveness of this strategy and have resulted in spray dates moving earlier in the season. So as just mentioned, as a result of these updates, the optimum spray dates have shifted earlier in the season, and in some cases this is up to a month earlier depending on the location. So here's a table showing you some areas with the original TimeRight date and the new dates based on the updates. And as you can see, the dates are at least a couple of weeks earlier for this updated TimeRight model. So this takes us into our pasture demonstration field trials undertaken in the last 2 years of this project. So for the final years of the project, it was decided that we were going to test the effectiveness of the updated TimeRight date and compare it to the original TimeRight date. To test this, we set up 3 sites with reasonable red-legged earth mite numbers, and the growers at each of these sites have been very accommodating and have undertaken all the spraying. So there is 1 site in the northern region on Murray's property and 2 sites in the western region on Wayne and Paul's property. And at each site, we had 3 plots set up consisting of an untreated plot, which was the unsprayed plot, a plot that was sprayed at the updated TimeRight date, and 1 plot that was sprayed at the old TimeRight date. The TimeRight sprays were also applied with a methylate, which, as I mentioned before, is known as LEMAT. And at each of these sites, red-legged earth mite numbers were assessed prior to the TimeRight sprays, and then again after the TimeRight sprays to check that the sprays had worked. And then the following season once mites had hatched, and then again in spring. So I'm just going to go over each of the sites that we set up. So the first site is in the northern region on Murray's property in Strathallan, and the site and the setup within that paddock is shown in the photo here. So we have the unsprayed plot here, the old time right date plot here, and the new time right date plot here. I've also included over here the updated time right date and the original time right dates and the dates that the sprays were applied. So given the turnaround of having to find a new site along with me only starting on the project, the updated time right plot was sprayed about 9 days after that best spray date, but was still undertaken within that ideal spray window. So here are the red-legged earth mite numbers that were present at the Strathallan site. So I have displayed both the graph and table with numbers so you can visualise them together, and I have done this for the other slides as well. So on the graph, the y-axis here is the number of mites per metre squared, and here is the sampling dates, with the green being the untreated plot, blue being the original time right date plot, and yellow being the updated time right date plot. So prior to the time right sprays, as you can see, red-legged earth mite numbers within each plot were between 2,600 and 4,000 mites per metre squared, with the untreated having less mites than the other two plots. After the time right sprays, as you can see, red-legged earth mite were only present in the unsprayed plot, and numbers were higher than in the previous sample, which is what happens in spring when red-legged earth mites start producing those diapause eggs. There is a significant increase in their numbers around this time. And no red-legged earth mites were present in any of the time right spray plots, which is expected and showed that the sprays worked. However, the results that we were most interested in are the red-legged earth mite numbers the following season at mite hatching, as showing here. And the results here show that the updated time right date treatment had significantly fewer mites hatched than both the untreated control and the original time right date at the start of the mite season. The level of reduction in mite numbers, as you can see down here, when compared to the untreated control, was 84.5% for the original time right date plot and 90.3% for the updated time right date. This reduction in mite numbers in the updated time right plot continued up until spring, with this treatment having significantly fewer red-legged earth mite than both the untreated control and the original time right date plot. So the original time right date plot did show a reduction in mite numbers at the start of the mite season in the May 2025 score date compared to the untreated control. However, this reduction was not sustained, and mite numbers in this treatment rebounded to levels similar to those in the untreated control by spring 2025. So the second site is in Mount Dryden at Wayne's property in the Western region, and the setup within that paddock is also shown in the photo here. And again, here are the dates with the updated and original time right dates and the date the sprays were applied. There was actually a month between these dates, which is quite a big difference. Again, and due to the weather, the updated time right date was sprayed after the date, but again was within that ideal spray window. So here are the red-legged earth mite numbers that were present at the Mount Dryden site. So prior to the time right spray, red-legged earth mite numbers were consistent across the three plots, as shown here. Due to the very dry spring in that region, though, in 2024, red-legged earth mite had already gone into diapause when we sampled after the time right spray. So there were very few or no mites present in all plots. However, the sprays had worked as expected, and at mite hatching the following season, the updated time right date had significantly fewer mites hatched than both the untreated control and the original time right date plot. So levels of reduction in mite numbers when compared to the untreated control was only 34.2% for the original time right date plot and 88.6% for the updated time right date. So this reduction in mite numbers in the updated time right plot continued up until spring 2025, with this treatment having significantly fewer red-legged earth mite than both the untreated control and the original time right date plots. So the original time right date did not reduce mite numbers below the untreated control plot at any score point in 2025, indicating that the mites had already produced their diapause eggs by the time the original time right date spray date was applied. So the third site was in Mount Cold Creek at Paul's property in the Western region, and the setup again within this paddock is shown in the photo here. Again, here are the updated and original time right dates for this site and the date the sprays were applied. And as with the previous site, there was a month between these dates. Again, due to the weather, the updated time right date plot was sprayed just after that date, but again was within that ideal spray window. And here are the red-legged earth mite numbers that were present at the Mount Coal Creek site, and these were pretty similar to the Mount Dryden site. So prior to the time right spray, red-legged earth mite numbers were consistent across the 3 plots. Again, due to the very dry spring in that region in 2024, red-legged earth mite had already gone into diapause when we sampled after the time right spray, so there were no mites present. However, the sprays had worked as expected, and at mite hatching the following season, the updated time right date had significantly fewer mites hatched, with no mites actually detected at all, compared to both the untreated control and the original time right treatment at the start of the mite season. The original time right date also had significantly fewer mites hatched than the untreated control at the start of the growing season. However, numbers were only suppressed by 36% as opposed to 100% in the updated time right plot. So we weren't able to get a spring sample for this paddock as the paddock had to be sprayed for cockchafers, but we still got the most important data at mite hatching. So overall, across all 3 trial sites, the updated time right date plots consistently resulted in significantly fewer mites the following season, both in the autumn, winter, after mites had hatched, and this continued throughout the season until spring, compared to the original time right date and the untreated control. So the results clearly demonstrate that spraying for red-legged earth mite at the updated time right date significantly improves the effectiveness of the strategy and is likely to provide growers with more reliable and season-long control of red-legged earth mites. So back over to you, Matt.
Thanks, Aston. So in conclusion, there were 7 demonstration sites involving multiple properties, real-life farms with multiple people, livestock, and conditions which consisted primarily, unfortunately, of drought for much of the project in Western Vic. Hopefully the rains are arriving down there and putting an end to those conditions. But the project has had real impact with farmers involved in the project either directly with on-farm demonstration sites and also indirectly through field days and webinars like this one, which, based on survey data that we've collected so far, has totaled to around 110,000 hectares of grazing area, 45,000 sheep and 12,000 cattle. So there's been some significant properties and farmers involved and making it have significant reach. The bug numbers were collected religiously from each site by CSER Australia members, such as Aston, and so those numbers and insecticidal impacts were assessed. Due to the drought conditions which persisted, not all sites were measured for dry matter, unfortunately, throughout the project, particularly the ones down in the west. However, where the dry matter data was able to be recorded, mainly from the irrigated pastures in Northern Vic during the final year of the project, the data collected showed an average of 630 kilograms of dry matter per hectare gain from controlling the red-legged earth mites and using the newly revised time right spray date. And so these figures illustrate that decision aid supported management, so the revised time right timing can generate measurable on-farm economic benefit through improved pasture production. So in using that figure, we used a $300 per tonne of dry matter figure to say we got a $154 per hectare benefit based on that extra dry matter grown after taking away a cost of $35 per hectare chemical costs from implementing those decision aid management tools. While the time right tools impact was able to be quantified in dry matter terms, conducting a robust economic analysis for the hatch timing tool and the severity risk calculator proved a little more challenging. These tools support timely and targeted monitoring and help reduce unnecessary sprays, yet their benefits are inherently preventative and risk reduction in nature, rather than tied to a single measurable output like dry matter. The economic benefits accrue through reduced input costs, extended chemical longevity, improved pasture production, especially around the critical stage of establishing a new pasture, whereby pasture might need to be resown if a red-legged earth mite infestation goes unchecked. Another point is that there is currently no threshold reported for when to control red-legged earth mite in your pasture. So it's an eye-opener as to the cost these little bugs can have on our pasture systems. This also shows the importance of these demonstration projects funded by MLA, and it's well worth a visit to the MLA PDS section on the MLA website to view all the other projects there. There's lots of really interesting stuff happening. Although not meant to be research, they are to demonstrate the products of research, and as is the case here, capture the implementation of online tools that were developed by research work and placed in the field on real livestock properties, and in effect observed, quantified, transferred into the practicality of how it works on farm, and the benefit of doing so added up. So if you can get involved with the MLA PDS project that helps your bottom line, yeah, I really do recommend you to do that. So I just want to say thanks to everyone now, just in wrapping up. Thanks to Aston from Caesar, Shanae and Rob from Perennial Pasture Systems, and our dedicated producers, especially the ones who hosted our sites. And of course, to you all for tuning in and listening to this webinar. Can we please, though, ask everyone to complete the online surveys? It's really important. So there are QR codes provided. If you can pause the recording if you're listening to this as a recording and take a screenshot, or however you can access those surveys, it would be greatly appreciated if you could complete those, as it shows the increase or the impact that these projects have out there, and the reach that we obtain as well, just with the numbers of surveys that we get back. So thank you, and be sure to go and try out those 3 online decision aid tools on the Caesar Australia website. Thank you very much.
Yeah, thank you.